All right, folks, welcome back. I think it's time to get going. So, as I said before, today I want to talk about the final exam. On Friday, we will have our normal homework and quiz day. So, I will expect to just sort of focus on the material for the quiz on Friday. But for today, we can talk about whatever you like. I don't have particular problems prepared to go over. I thought I could just show you the review sheet and then we can just talk about anything that anybody likes. So I'm going to paste into the chat a link. Sorry, I lost it. All right, I hope you can all see that link I pasted into the chat. Check it out. This is the review sheet, which includes stuff for the whole semester. So you will notice if you look at the end, the last page or two, at the top of page 4, you will see this is the new stuff. So the test is going to be cumulative. That is anything for the whole semester might be on the test, but at least 1/3 of the test will focus on the new stuff. So you want to make sure you're good with the new stuff and also with the old stuff too. The test you can see at the very beginning of the review sheet. Our test, we are section 10 here, and our test is on Friday, December 18, which is one of the last possible exam days at 11:30 a.m. The test is scheduled for 3 hours. All final exams at Fairfield are by default scheduled for 3 hours, and you can take the whole 3 hours, but I'm not going to make the test super long. Probably I'm planning on making it maybe like 1.5 times the length of our usual in-class tests. So I'm not going to try to make you fill that whole time, but you are entitled to the whole 3 hours if you want it. Does anybody have basic questions about the test, the format of the test or whatever? It'll be in terms of format just like our other tests. Any questions about logistics or anything like that? Nope. All right. Maybe we can just talk about some of these topics then. So take a look at the review sheet and let me know. What do you want to see some more of? We can talk about old stuff, new stuff, whatever you want.
Can we use some antiderivative stuff, just like from episode 25?
Sure. Yeah. Thank you for being the first person to say something. Yeah. Simple antiderivatives, like without u substitutions. I'll try to invent some that are similar to the one on the paper. How about? Let me just write a bunch here. Let's say 7. How about that? I got a bunch of things that are all being added together, and when you see a bunch of things that are all added together, it means you can do each of them separately. And for each one, you'll just have to decide sort of what is the appropriate rule or formula or whatever, the appropriate thing to do in each case. So the first one is the simplest, I believe. Just a power of x with a coefficient in front of it, 7x to the 5. Can anybody tell me what's the antiderivative of that? Hope you remember how to do these.
35x to the 4th.
It sounds like that's the derivative. You want the antiderivative. In the antiderivative, you should be increasing the power by 1 and dividing by the power. Yes, I heard 7 times 1/6 x to the 6. Great. So that's the antiderivative of the first one. How about x to the 5 over 7? Well, this is similar, only it's not 7 in front, but you should consider this over 7 as like a 1/7, right? This right here is the same as 1/7 x to the 5. All right, so that's sort of a little micro trick that you need to do when you have a division by a constant. Turn it into a coefficient. And so what is that? That would end up being the 1/7 stays like it is, and then again, x to the 5 becomes 1/6 x to the 6, right? Okay, how about 5 to the power 7x? So when you see that, you should realize that this is an exponential function. The x is inside the exponent, and in such a case, you need to use a special formula. And if you notice on the review sheet, if you flip to the end, you will see a big list of formulas that I'm going to tell you on the test. And one of those is what you want. So the list of formulas includes something like this. Integral of a to the kx. That's what I'm looking at here because I have some number down here, some constant coefficient on x inside the exponent. So this will fit perfectly this format. And the answer, if you look in the formula, is 1 over k ln a to the kx. So this is what we're going to do for that 5 to the power 7x. 1 over k ln a to the kx, where in this case the a is 5. That's the number downstairs here. And then the k is the number inside the exponent, which is 7. So I plug in over here. A is 5, k is 7. I go 1 over 7 ln 5, 5 to the 7x, like that. So that's what this, these are just, each one comes from one of those up there. All right. And finally, 7 times 5 to the x. So in this one, the 7 is just a coefficient, so it will remain as a 7 in front of whatever the answer is. And then really all you have to think about is 5 to the power x. And again, we have a formula for a to the power x, and it says 1 over ln a to the x. And so here I go, I'm using that formula that I just wrote, but with a equals 5. 1 over ln 5, 5 to the x. That's it. And then I, of course, plus c is the end of that one. All right. This is fairly simple, although you have to look carefully at it to judge which formula to use. But other than that, it's a matter of just kind of properly plugging into the appropriate formula. Let's try. I got maybe two more things we could do with this. How about x to the 5 minus x to the 8 over 3x dx? And how about, I got two more here. Actually, let's do this second one that I'm writing first. X cubed times 3x squared plus x minus 7. How about this? Let's do that second one first. I think it's maybe slightly easier, then we'll do that other one. Anybody have a suggestion for that second one there? I'm trying to do this one here. The fact that you see parentheses might suggest that maybe a u substitution would work, but actually in this example, the u substitution is not necessary, and in fact, it would not work if you tried to do it. Anybody have another idea? What could we do?
Could you multiply it through?
Yeah, multiply it through. Do like the you know, distribute this thing here, right? Like that. Then it will, once you do that, it'll just look like a polynomial inside, and you just do the antiderivative. What are you going to do? So x cubed times 3x squared. In this case, we should be adding exponents. I get 3x to the 5. And then plus x cubed times x. I get x to the 4. And then x cubed times negative 7. Negative 7x cubed, right? And now, this being a polynomial, it's easy to just go down the list and do the antiderivative every time. Every time you increase the power by 1 and divide by the power in the front. So I get 3 1/6 x to the 6 plus 1/5 x to the 5th minus 7 times 1/4 x to the 4 plus c. So this is the old distribute it trick. Not much of a trick, I guess. All right. Any questions about that one? Okay, and then let's go back to this other one that I wrote. This one's a little, I don't know, a little bit harder, maybe. Grab this, put it over here. Look at that. Technology, the tricknology. Okay, what do you want to do with this one? Any suggestions here? Again, you might be tempted to do the use substitution, but it's not going to work in this case.
Would you change it so it?
Yeah, go ahead.
Would you change it so when you like divide, so it'd be like instead of divide by 3x, maybe multiply by 1/3x?
Yeah, this is a good idea. I think I'm going to go a little farther. So write it as multiplication instead, with the intention of distributing. And instead of 3x, I'm going to use the negative exponent. It's going to become 1/3 and then x to the minus 1. All right, and then the reason you do this is so that in the next step you can distribute. And then from there it goes similarly to the example that we just did. You got to make sure, why did this turn into a 1/3? Well, it's because it used to be a 3 in the denominator. You can't just bring it up and leave it as like times 3, because it's not times 3. It's really divided by 3. In other words, times 1/3. So make sure when you're pulling things out of a denominator like this, you put the negative exponent on the x, and you make the 3 into a 1/3. You could also write 3 to the power minus 1 if you want. Just use a negative exponent on both of them. That would be correct, although slightly weird to write 3 to the power minus 1. But that is the same as 1/3. Anyway, let's distribute it. Oops. Is okay. I'm still writing the integral sign. I hope you're still writing the integral sign because I'm not doing the antiderivatives yet. That will happen, I suppose, after the next step. Distributing 1/3 x to the minus 1 times x to the 5. We should be adding the exponents, so it's going to be 1/3 x to the 4, and then minus the other one, 1/3 x to the 7. All right, I just distributed, adding the exponents. And finally, we're going to do the antiderivative. We haven't done the antiderivative yet. We're going to increase the power by 1 and divide by the power. So it becomes 1/3 stays in front as a coefficient, and then 1/5 x to the 5th minus 1/3 as usual, 1/8 x to the 8th, and a plus c, of course. All right. I think that's a good kind of, you know, a good variety of simple integrals that do not require the use substitution. Any questions about those ones, or no? All right, what else do you want to talk about?
Can we do examples from like the beginning episodes, like 4 and 5?
Sure. Let me refresh my memory. Okay, continuity. Yeah. So let's just try and do ones just like what I see on the sheet here. Identify discontinuities by looking at a graph. This is very easy if you know what you're doing. So let's say I have a graph. Let's say I have a graph like this, and it's maybe like that. Has an asymptote maybe, and then goes like that. Let's say this is my graph. Find any discontinuities. Let's do it. So let's find x values of any discontinuities. Well, what do you think? You're looking for points at which there's some sort of a break in the graph. Can anybody shout it out? Just tell me the x value. Three, yeah, x equals 3 is one. That's right here. Because of this weird sort of jumpity jump in the function. There's like a break in the graph right there. That's a discontinuity. Any others? I can see one other.
5.
5, yeah. Also right here on the asymptote, you can see the curve has a sort of a gap in it right there. So x equals 3, x equals 5. All right. If that's all I ask you, find the x values of any discontinuities. That's it. It's a simple question. I could also ask you, looking at the graph, to find various limits. So let's try and do that. Let's find limit as x goes to 3 from the left, and limit as x goes to 3 from the right, and limit as x goes to 3, and f of 3. Remember this kind of thing? We spent a week or two talking about problems like this. Remember what these questions, when it says lim, you are looking for where does the curve go when you get close to 3. So this first question, lim as x goes to 3 from the left, I'll do this one sort of in blue. Where you should be looking is along the curve coming towards this point from the left side. That means if I am traveling along this curve like this, from the left side towards the point, where does the y value approach? I didn't label the y-axis. How about I'll make markings like that, just so we can answer these questions specifically. Where does the y value approach as I come into that point from the left? The answer is 3, right? Y equals 3 is the y value at that point. So this, my answer is 3. All right. What about from the right side? Maybe I'll indicate this in red. From the right side, it means you come in. Uh-oh. Am I doing all right? Something weird's going on with my video. You still see me?
Yeah, we can see your board.
All right. Can you still see my beautiful face? I guess.
Yes.
Okay. Thank you. Thank you for saying that. I know I need a haircut. My haircut place shut down for a week or something. I'm going tomorrow. Don't worry. It's okay. Don't mention it on your course evaluations. Oh, I meant to say that actually. Folks who came to the Zoom yesterday, I already advertised this, but I hope that you will all have a moment to do the class evaluations. There is a link on our class website near the homeworks, as always, where you can do that. I do appreciate any comments that you have. Don't mention my hair. I'm getting a cut tomorrow. By the way, you shouldn't mention anybody's hair when you do these evaluations. I talk to my female colleagues from time to time, and they say every time somebody comments on their appearance, I'll tell you how many times people have commented on my appearance on the evaluations. The answer is 0 times, and that is as it should be. We got enough to worry about. Don't go talking about your professor's dress or something. Be a professional. She's a professional. You can be too. Oh, my video just messed up again. All right, no more talking about my hair. I think I have too much stuff running on my computer at once. It's all right. The limit as x goes to 3 from the right. Okay, I'm gonna look along the curve, but this time from the other side, from the right side. I just drew this little arrow here. Approaching from this side. What is the y value approach? It seems to me the y value approaches. The y value approaches y equals 1. I hope you can hear me at least. I can tell my video's doing messed up things. 1. All right. I'm gonna try to quit some other things on my computer here. Hopefully make it a little bit better. Sorry, give me a moment. Come on, yo. I'm still here. Can you still hear me? Thank you for your patience. I don't know what's going on here. I'm not sure if anybody can hear me. My computer's having serious problems. Even the clock stopped for a moment. Can you guys hear me? Somebody say something.
I can hear you.
All right. I think I'm feeling good now. Okay. Sorry about that. Hopefully I'm back. Have you had enough time to look at this picture? What do you say? What's the limit as x goes to 3?
Does it not exist?
Yeah, that one does not exist. Right here, this one does not exist. Thank you for staying on the line. It's because these two, when you come from the left and from the right, they get two different answers. Oh, come on, man. I was doing so good. It's because you get two different values in that limit, and that means the overall limit does not exist. All right. And then what about f of 3? That means where is the y value actually when you're looking at x equal 3? And that's the only time in which this filled in circle, empty circle matters. And f of 3, you use the filled in circle, it is 3. All right. I think I'm feeling better now about the video. Okay. This is a typical continuity on a graph sort of problem. Any questions about any of those? All right, let's do some of these continuity for things that are not on a graph. So similar kinds of questions, but I will tell you an equation and ask you about various continuity properties. How about how about this? Tell me about any discontinuities of this function. Find any discontinuities. And then this is a typical book question. They say find any discontinuities of the function and then find, well, I'll say for each one, find the limit as x approaches a of f of x. So find any discontinuities, and then for each of those discontinuities, find the limit as x approaches that point of this function. So find any discontinuities. First of all, you just look at this formula here. Anybody remember how to do this? What should I be looking for in terms of discontinuities?
When x is equal to 0?
Yeah, I'm looking for places where x equals 0. Sorry, I meant to say I'm looking for places where the denominator equals 0. And in this example, that means x equals 0, right? So to find this, I'm going to say set denominator equal to 0. If the denominator were a more complicated formula, you might have to do some solving for x to figure this out. But in this example, it's obvious that x equals 0 is a discontinuity. I wrote discontinuity. x equals 0 is a discontinuity. Ah, it's not working out today. Sorry. I know what this problem means. This is easy. The thing goes black at random. I have to pull the plug and reinsert the plug. It dings. And then it comes back. Okay, we're back. Yeah, x equals 0 is a discontinuity. Okay, and then it said for each one, find the limit as x approaches whatever. So I want to find limit as x goes to 0, f of x, which of course is lim x goes to 0 of x minus 3 squared minus 9 over x. All right? Anybody remember how to do this? The limit as x goes to 0 of something. What you think? Maybe I'll get us started. You should try to plug the number in. So in this case, I'm taking the limit as x goes to 0. You should just try to plug in x equals 0. What do we get in this example? 0 minus 3 squared minus 9 over 0. Now I have a 0 in the bottom, which might mean the limit does not exist. Remember, what happens is if you get 0 on the bottom and something that's not 0 on top, then the limit does not exist. If you get 0 on the top and the bottom, that means you need to, it doesn't mean anything about the limit. It means you need to go back and somehow simplify. So let's see what we get here. Up top, this inside the parentheses is negative 3. I square it, I get 9. So this is 9 minus 9 over 0, which is 0 over 0, which means we need to go back and simplify. So if I go back, I mean go back to here, right? What can we do to simplify this? I suppose the only thing to do is to square out the top there, x minus 3 squared. So you got to do, yeah, x minus 3 like that, right? And square them out. What do you get? On the front end, you're doing the FOIL here, right? On the front, you get x squared. In the middle, you get minus 3x. On the outside, you also get minus 3x, so that ends up adding together, minus 6x. And then the negative 3's add up or multiply together and give you a plus 9. All right? Then I go minus 9. Then I divide by x. What can we do to simplify here? I suppose the 9's will cancel, right? Cancel that. What else can happen? Well, I think we can factor x out of the top and cancel x. So this is going to be lim x goes to 0. Factor out x on the top, like that. And then we can cancel these x's. And I end up finally with lim x goes to 0 of x minus 6. Now this is as simple as it's going to get. We can now plug in the value x equals 0, and we get 0 minus 6, which is negative 6. That's the answer. All right, so this is finding the limit of something like that. Any thoughts about that one? Questions about how I did it? And I don't know if you're sick of this yet, but one more type of question that you could see from that section is if it's like a piecewise. Let's say something like x plus 3 if x is less than 1, and x squared minus 7 if x is greater than or equal to 1. Find any discontinuities of this one. Any discontinuities? What? I don't know what's going on now. All right. I quit a bunch of stuff, but it's still... All right. I'm just going to keep going. Anyone remember how to do this? I remember how to do this. This one, we have these two formulas. They are ordinary formulas. Like they have no discontinuities by themselves. But you need to check the value when they are supposed to meet up. We have two separate things. Like as a graph, what we have is, here's one. To the left of the one, it looks like a line, something like that. And to the right of the one, it looks like a parabola, which I think is, it's something like that, right? So it looks to me like this is probably going to be a discontinuity, but you need to check, do these two parts actually line up, or are they separated like it looks like in that picture that I just drew? I just made up that picture, but it seems to me they're probably not going to line up. But the way to check is to plug this number, x = 1, into both equations. And in fact, when you do it to the first equation, really what I'm doing is lim x goes to 1 from the left. Plugging into the first equation is 1 plus 3, which is 4. The reason why that equals the lim as x goes to 1 from the left is because the first formula is the one which you use when x values are slightly less than 1. Right? And then the other formula will give me the limit as x goes to 1 from the right. When values are slightly greater than 1, you use the second formula. You get 1 squared minus 7, which is 1 minus 7, negative 6. These are different. And so that means x = 1 is a discontinuity. Right, that's how we do that. Any questions about that? And I think that's enough talk about continuity. I didn't mean to spend so much time on that, but because of my technical difficulties. What else should we talk about? Maybe someone who's not named Avery. We had 2 questions. 2 Averys.
Can we talk about what we did from the episodes from last week?
Sure. The estimating with the rectangles and the Simpson and trapezoid?
Yeah.
Yeah, sure. So the typical setup would be I have something like an integral, say the integral from 2 to 6 of 3x squared minus 7x dx. How about I'll give you parts here. Part A, estimate the integral using n = 4 with midpoints. I wrote with. I meant to write with midpoints, but it came out as with. Estimate the integral using n = 4 with midpoints. How about let's estimate using Simpson's rule. Simpson's rule. Again, n = 4. And then how about let's find the true value, not an estimation, but the actual, the true value. Not an estimation, but the real answer of what it really is. All right. The true value is actually this week's material. For that, you would use the fundamental theorem of calculus. How about for the part A and the part B? Estimate the integral using n = 4 with the midpoints. Let's do A first. So you should sort of make yourself a little diagram of the interval. I find this helpful. Divide this into 4 equal bits and figure out where those points should go. I usually try to make them work out nicely for you. In this case, it's just 2, 3, 4, 5, 6. And we need to find the midpoints of those intervals. Those are these points here. These are the 4 points which we intend to actually plug into the function. They are 2.5, 3.5, 4.5, 5.5, right? And so, what's the delta x in this case? The delta x would be the width of each small interval, which in this case is just 1. Remember, you can always find the delta x by doing b minus a over n. In this case, it would be 6 minus 2 over 4, which that is 1. Or usually you can just kind of figure it out by common sense, looking at your points. Okay, anyway, what's my answer then? Remember how you do the midpoint thing? You put delta x on the outside of a bunch of parentheses. To do the midpoints, you put delta x on the outside, and then on the inside, you add together function values with those midpoints plugged into it. So I'm going to go f of 2.5 plus f of 3.5, f of 4.5 plus f of 5.5. And what is that? Well, it's 1 on the outside. You can omit that. It doesn't matter. 1 times a bunch of stuff is irrelevant. And then what f means is 3x squared minus 7x. So it's 3 times 2.5 squared minus 7 times 2.5 plus, etc. You do this for all of those points. The last one is going to say 3 times 5.5 squared minus 7 times 5.5, right? And I would expect you to just leave your answer like that because you're not going to have a calculator. I noticed on the quiz, actually, from last week's quiz, some people heroically tried to compute this thing by hand. It was not necessary. I didn't expect you. On the quiz, it required squaring some weird numbers. Don't do that. Just leave it like this. That's what I meant when I said you don't have to simplify. All right, that's the midpoints. Any questions about that part? Dems the midpoints. All right, how about part B? Using Simpson's rule with n equals 4. So it's going to look similar, only, first of all, I'm not going to use the midpoints this time. So for Simpson, I'm going to use these 4 values, actually 5 values, just what they are, 2, 3, 4, 5, and 6. And you have to remember the Simpson rule formula. Actually, you don't have to remember it because it's part of the list on the review sheet of the formulas that I'm going to tell you. If you look at the very end, there's an unfortunate page break from page 4 to 5 on the review sheet, but all of those will be given to you on the test. Simpson's rule, you'll have to recognize which is which. Simpson's rule is the very last one. So it's b minus a over 3n, which in this case is 6 minus 2 over 3 times 4. B and the a are the 2 endpoints on the ends. N is still 4. All right, and then on the inside of Simpson's rule, you have to use the correct pattern. My points here are these, right? 2, 3, 4, 5, 6. The Simpson's rule says no coefficient on the first one, a 4 on the next one, a 2 on the next one. Then you alternate 4s and 2s all the way down, although there's not much to do in this one. 4f of 5 times, and then the last one has no coefficient on it, like that. All right, this is the setup for Simpson's rule. No coefficient on the first one or the last one. The ones in the middle have 4s and 2s, starting with a 4, and if you do it right, it will always end up with a 4 also. If it ever ends up with a 2, it means you messed it up somehow. Okay, and then you don't need to simplify this whole thing, but you shouldn't leave it like that because I want to see that you know what the f means. So as my final answer, I would say this, and then f of 2 means, I've forgotten my function. 3x squared minus 7x is the function. So it's 3 times 2 squared minus 7 times 2 plus 4 times 3 times 3 squared minus 7 times 3 plus 2 times 3 times 4 squared minus 7 times 4 plus 4 times 3 times 5 squared minus 7 times 5 plus the last one is 6. 3 times 6 squared minus 7 times 6. All right, that's my answer for Simpson's rule. And again, I would not expect you to simplify beyond that. All right. And then finally, part C was to find the actual answer to the integral. So the integral was integral 2 to 6, 3x squared minus 7x. dx. How do we find the real value of this? Not an approximation, but just the actual, what it actually is. You use the fundamental theorem of calculus to find the exact answer for a definite integral. So I'm going to do my antiderivatives. It's 3 times 1/3 x to the cubed minus 7 times 1/2 x squared. And then I have to plug in 6 and 2. First I plug the 6. I get 3 times 1/3 times 6 cubed minus 7 times 1/2 times 6 squared minus, and now I plug in the 2. 3 times 1/3 times 2 cubed minus 7 times 1/2 times 2 squared. And this is the true answer. If you are in the habit of plugging things into your calculator, these answers from, you know, the midpoint, the Simpson, and the final, the true value of this thing, all three of those answers should be close to one another, even though they all look quite different. The last one is the true value of the definite integral. The other two are approximations, so they should be fairly close, but not the same. All right, I hope that's what you wanted to see. Any questions about those? All right, we got about 7 minutes left. I think that's time for another one.
Can we do some U substitution stuff?
Sure. Yeah, the U substitutions are pretty tricky in my opinion. Let's see. How about 3x squared times 5 to the (8x cubed). This is kind of a tricky one. U substitutions, in my opinion, are maybe one of the hardest things for the whole semester. That's just my own opinion. I don't know if you agree with me. Let's try it. So the first thing you should consider is just, do I really have to do the U substitution at all? I know on the third exam, there was a U substitution problem that actually a lot of people didn't realize they needed to do the U substitution. They just tried to do some kind of simpler trick, and it didn't work. How do you know that you should do a U substitution here? So one tip-off is the multiplication here. This multiplication right here, whoa, sorry, I meant to point at it. This multiplication right here is, there's no good way typically to handle multiplication inside of an integral. Sometimes you can deal with multiplication by distributing, like the examples I did at the beginning today. We distributed, and that allowed us to do the antiderivative with the multiplication. But here you can't, there's nothing, you can't do anything with this multiplication. You can't distribute. I mean, this is inside an exponent, so there's no way to combine this all together in a different way. So I'm going to do the U substitution. When we do U substitution, generally choose the U to be the inside of something. What do you want to choose the U in this case?
X squared.
Oh, come on, man. Can you still hear me?
Yeah, we can hear you.
Oh, all right. Not x squared. Sorry, you can't see the thing anymore. I'm just waiting for it to come back. I apologize for my technical issues. I did so well this semester. You generally, remember, you want to choose the inside of something. This can sometimes be the inside of parentheses, maybe the inside of a square root sign, maybe the inside of an exponent. What do you say?
Maybe 8x to the third?
Yeah, that's really your only other choice. But the inside of the exponent is generally a good idea if you see exponential functions. So I'm going to pick 8x to the third. All right. The next thing to do in a U substitution is to figure out the du. This is, the du is always the derivative of the u. So in this case, it's going to be 24x squared. Right? The 3 comes down, multiplies onto the 8, you get 24. And then du always includes dx. So the du is 24x squared dx. And then it is usually helpful in a U substitution when you have a constant on the front of the du, which you usually do. you usually want to divide that constant to the other side. So I'm going to write it this way. 1 over 24 du is x squared dx. All right. This is my little setup here. Let's try and actually plug this stuff in. So when I go to substitute, remember your goal is to rewrite everything so that it uses only u's and no x's. I'm going to begin that process by just sticking the u right where it goes. So u is 8x cubed, which goes right here. So I'm going to begin by keeping everything like it is, but put the u right there. All right. And then, you know, I have this other stuff left over. I want to try and sort of clean it up. And I do that by writing the u stuff first and then push the x stuff to the end all together. Would you mind if I also bring the 3 outside the integral here? The 3, what? Sorry about that. The 3 is a constant multiple on the inside, so I'm going to factor the 3 out. And then what remains on the inside is 5 to the power u, and then x squared dx. So I just shuffled things around there. The 3 being a constant multiple, you can move it all the way out of the integral. 5 to the u, I don't know, do you feel like, can I just move the 5 out also? No, the 5 is not a constant multiple. The 5 is the base of an exponential function. And because it has that u on it, you can't move it out of the integral. If it was 5 times u, you could, but it's 5 to the power u, which is a very different thing. All right, what am I supposed to do now with x squared dx? Well, I had set this up earlier. X squared dx is right here. It is 1 over 24 times du. So I get 3 still on the outside, 5 to the power u, and then 1 over 24 du. All right, and now no x's remain. We're not quite done yet, but you should be feeling good about this. I haven't done the antiderivative yet. To prepare for that, let's pull the 1 over 24 out of the integral also. That is a constant multiple inside the integral. And it'll just end up out here with the 3. And now I got to do the integral. What is the integral of 5 to the power u? Well, I'm just gonna do this because we got to go in a moment. You need to remember this formula: a to the power x dx, right? Because that's what I'm looking at here, 5 to the power u. And the formula says this is 1 over ln a to the x. Plus c. So what I get is 3 over 24 times 1 over ln 5 times 5 to the u plus c. All right, I just used the formula for exponential function with a base other than e. All right. And then, almost done, there's one more step. Anybody remember the last step in the u substitution? Everybody's favorite step.
Do you have to put the 8x squared or cubed back in?
Yeah, plug the x's back in for u. So u is off the screen now. U is 8x cubed. So my final answer here is all of this, but with the 8x cubed in there. 3 over 24, 1 over natural log 5, 5 to the power 8x cubed. That's my final answer. All right, that's kind of a tough one. And we're out of time. Sorry I wasted time with my technical issues. I hope you saw most of it. I am going to upload this on YouTube like I always do. I also did, I'm going to upload the other classes too, in which I did totally different examples. So you can check that one out if you want more review stuff. All right, I guess I'll see you all on Friday.